Hi everybody, today we're going to have a look at some geometric proofs. In a geometric proof, we try and use our geometric knowledge to show that something is similar, something is congruent, two sides are equal, two angles are equal, and today we're going to focus on similarity. So in our first shape, we're looking to find A and B. Here they are over here, A and B. And if we can somehow show that some triangles are similar, we might be able to solve that. So our first step should be to name the shape and the vertices so that we can describe what we're trying to do. So I've done that here. I've gone A, B, C, D, and E. And the first thing we should look for is can we prove any angle properties. So in this case, I've got two parallel lines, so that's probably a bit of a hint. And given that, I know that this angle here is alternate to this one, and this one is alternate to this one, and these angles here are going to be vertically opposite. So we have an angle property and two parallel line properties. And I've written them here, which means that we've got all the angles for AEB and all the angles for DEC, and proven that they've got corresponding angles in each. Therefore, I can say that DEC is similar to BEA, these two triangles, by AAA. And note that in each step of my proof, I've got a statement and a reason. Now, once we've shown that they are similar, we then know that the ratio of sides is going to be equal. So over here, we have AB and DC. They are corresponding sides. That's going to give us the ratio of all the sides. So AB divided by DC, the image divided by the object, is equal to 3. Now, once we know that the ratio is 3, this side is congruent to this side is congruent to this side is congruent to that side. We can probably show that by putting in the angles. This angle here and this angle here are identical, and this angle here and this angle here are identical, which means and I suppose put the third one in here just to make it easy to talk about it. Let's make that a square. This one over here is a square. Okay, so if we wanted to know which side B is corresponding to, this B side here is corresponding to BE. BE is going to be between the circle and the square. Here's the circle and the square. So this side is going to be corresponding to that side. So EB over DE. What did I do? I started with AB over D. No, I didn't. EA over CE. Okay. So EA squared to cross to CE. CE cross to square. I've probably done that back to front. If I was doing it properly, I would have done squared across in both places and said EC. So it doesn't matter. It just means 12 on A is equal to 3 on 1, which will give me 4. And do the same with EB. EB on ED, so this side is corresponding to this side on BA is equal to 3 on 1 again, and B would have to be 3. B would have to be 15 to get 3. So first one solved. Let's look at the second one. In this case, we have a triangle with some right angle triangles inside of it. We might have thought of RHS to begin with, but we haven't been given the hypotenuse. And even if we tried to work it out with Pythagoras, we'd end up with an unknown over here, so it isn't going to be RHS. We're probably better off going back to one of the others. So let's have a look. We know that this angle here is going to be shared between the big triangle and the little triangle. That could be one angle. We've been given a right angle in both cases. They're equal. So that's an angle. That's the same. Now, if we know two angles in a triangle, we always know the third angle because that's, if we look at the triangle properties of angles adding to 180, if we know 2, the third one's always going to be the same. So I've stated that over here. Angle A is a shared angle. That's that one. Angle B and angle D are 90. That's these two. And angle C is equal to angle E. This one must be equal to that one because they're the third angle in a triangle and the other two are the same. So we can therefore say triangle ADE, this small triangle, is similar to the triangle ABC. And if we wrote down the ratio of the sides, I think this time we're doing small triangle to big triangle. So this length here is going to be in ratio with this side here, now that we've proved that they are similar. So 12 divided by 18 is 2/3. Now, if we want to know the ratio of the big length to the little length, or in fact, the little length to the big length, it's going to be this length x divided by the big length 10 plus x is equal to 2/3 because we did a little triangle to big triangle. Multiply both sides by 10 plus x, multiply both sides by 3, you get this equation here. Expand the bracket, subtract 2x from both sides, you end up with x equals 20. Now, if you write your proof out like this, that will be full marks in my book, and I will give myself a tick. Tick for my statements, a tick for my similarity, a tick for finding the ratio, and a tick for the answer. So I hope that was okay. Maybe I should do the same with the other one to show you where the marks are. 1 mark here, 1 mark here, 1 mark here, and we've got 2 questions this time, one for this one and one for that one. So what would the behaviors be? Did I write down the statement and reasons for my proof? Did I write down what it was that I was trying to do? Did I determine the ratio correctly? Could I use the ratio to solve the problem? So there you go. I hope that was helpful, and I'll see you in the next one.